Dear fellow researchers, I would like to present you a report on essence and characteristics of contact measurements technique for the amplitude of vibration movement of the test material point. A round mark is placed on the surface of the control object. The test material point is located in the center of this mark. The mark image is recorded by a distant device, for example digital camera, placed at distance h from the object surface. The object plane is the plane containing the mark in the absence of vibration. The recording device records the mark image with and without vibrations. Original focused image of marks with the registering device at a distance of h, which is equal to 55 mm from the surface of the object. On the slide 4, out of focus image of marks with the registering device at the distance of h, which is equal to 45 mm from the surface of the object. For the slide 5, vibration movement of the studied material point along z-axis is determined according to the formula. To define the coefficient p, it is necessary to make preliminary calibration measurements in the absence of vibration. The distance from the object plane to the recording device becomes equal to h as L. That is, the results of calibrating measurements are used for calculating calibrating radius increase the mark image L. Then, the coefficient of z-axis vibration movement is studied material point P is determined. At the stage of main measurement, in the presence of vibration, the radius L of vibration induced, blurred image and the vibration increase L of the image radius are calculated. Following that, using formula, the z-axis vibration movement of the material point is determined. Slide 6. What differs the vibration measurement technique suggested in this report from others is that the radius measurement of the image is not direct, but an indirect one. At first, the measurement of surface area of the tag image is performed in square raster units. Following that, image radius is calculated according to the formula. Surface area of 1 pixel equals 1 square raster unit. From this follows that the surface area of the tag image expressed in square raster units is measured with the number of pixels belonging to that image. As a result, the error of measuring the image radius will be 1–2 orders less than the linear raster unit. The dependence of the relative error on the specified value of the amplitude of vibration movement along the z-axis was received on the basis of the experimental data and the mathematical expressions given in this report. This is a monotone decreasing dependency. The value of amplitude of vibration movement during which the curve of the graph intersects the horizontal line corresponding to the relative errors of 100% is the meteorological sensitivity threshold of the system. Table 1 shows the values of the relative errors in measurements at vibration movements. Slide 8. Research originality and main results. Research originality consists in the first use of analysis of the blue of the round mark image with the aim of measuring the amplitude of vibration movement of the material point. Main results. We have formulated the problem of creating a new technique of contactless measurements of vibration movement of the material point on the surface of controlled object. We have analyzed the state of affairs in the field of vibration measurement. We have justified the rationale and the efficiency of the suggested technique. We have outlined the suggested measurement technique. We have conducted and justified the sequence of measurements and calculations. We have evaluated the errors of amplitude measurements for vibration movement on the basis of suggested method. We have presented the results of experimental studies. Thank you for your attention.